All right, so here we go on 5.8. Oops, yeah, but those are examples. Cool. All right, so basically, here we go on these examples. Again, we got to remember, if anything, that we have 45, 45, 90, right? It's going to be x root 2. So, and then of course 30, 60, 90 is going to be x root 3, 2x. At least that's how I do it. So in this case, again, I'm just going to, our legs are always x. So so I'm not really worried that this is called x. So x root 2. So I'm just going to get all the sides anyway. This is 14. This is 14. This is 14 root 2. And I'll just circle the one that we're looking for. All right. So this is going to be x root 2. So here's the equation that I had, right? Once I label it, we divide both sides by root 2. So we get 12 over root 2. And that's going to be our x. We do have to rationalize it. I'm going to start doing this in my head, but this is basically what happens. So 12 root 2 over 2 is just 6 root 2. Okay. In this case, we have x root 2. Now, so we have x root 2 here. Now, hopefully we see that if I divide both sides by root 2, that cancels and that cancels. So x just equals 9. So 9 and 9, right? All right, more 45, 45, 90. We got x. And again, you can always tell the sides that are legs because they're the ones that are going to make the right angle. But x, or they'd be congruent, or they'd be opposite of 45 degrees angle. So x root 2. So 15 equals x radical 2. When we divide 15 by radical 2, we get this. So when we rationalize, we get 15 root 2 over 2, and that doesn't simplify. So you know what? That's okay. That's what our x is going to be. In this case, we get, again, I'm going to not call that x, I'll call this x, and this is going to be my x root 2 side. And so we know that x is 4 root 2, so that's going to be 4 root 2. This is going to be 4 root 2. This is going to be 4 root 2, because that's x root 2. Right, so 4 root 2, just so we had the first one of these, that's root 2 times root 2 is just 2, so we get 8. All right, in this case, we get x root 2. And again, hopefully we see that the 2's will cancel out, and so x is just 18. Okay, now we get 45, 45, 90. So I'm still going to label them. Opposite of the 30s, I'm going to call x. Opposite of the 60, I'm going to call x root 3. Opposite of the 90 is 2x. So look, we got 2x equals 6. So we can do x equals 3. So we have x equals 3, which means this side right here is just going to be 3 radical 3. All right, opposite this is x. Opposite the 90 is going to be 2x. Opposite the 15, this is going to be x radical, the 60, which would be here, right, would be x radical 3. So 15, when we divide both sides by radical 3, we get 15 over radical 3. And to rationalize that, top and bottom by radical 3, so 15 root 3 over 3, which is just going to be 5 root 3. All right, in this case, we get x here, we get our x root 3 here, and we get our 2x here. So we have x, we can say x root 3, so 7 root 3 is just 7 times 3, which is 21. So this side is going to be 21. Go back to our x, 7. So if this is x, then 2x is going to be 14 root 3. All right. In this case, we know our 30s here, so that's going to be our x value. We have x root 3 is going to be here, and we have our 2x is going to be here. So if x is 24, 2x is going to be 48, and x radical 3 is going to be 24 radical 3. So basically go back, find the x, and then use the x if you can. All right, so in this case, we cross with 30. Oops, that was actually x. We have x root 3 here, and our hypotenuse is 2x. So if 2x equals 10 root 3, we divide by 2, and we get 5 root 3. So 5 root 3 is x. So 5 root 3 would just be 5 times 3, which is just 15. So again, that would have been like 5 root 3, because this whole thing is our x. And so x times root 3. All right, so we get x across from the 30, x root 3 across from our 60, and then across from our 90, we get our 2x. So we actually, that was bad. We had x root 3 equals 2. So 2 root 3 over 3 is what it's going to end up being for our x, which is fine. Again, once I sort of simplify that, and then, so that's our x value. And then when we get 2x, we're just going to double that. So doubling 2 root 3 over 3 is just going to be 4 root 3 over 3. So this is 2 root 3 over 3. Okay, 3's. All right. Now, so the perimeter and area of each figure. Actually, the first two were part of the examples, so I'm just going to no, I'll just do them. Best way to do this is just draw this out, right? So we have a 45, 45, 90, and a hypotenuse is 12. So I know it's going to be x, x, x root 3, x root 2. Almost got you, almost. All right, so once we divide by 2, 12 over radical 2, it ends up just sort of rationalizing into 6 radical 2 is basically x, right? So both sides are 6 radical 2, okay? So if both legs are 6 radical 2, to find the perimeter, it's going to be 6 radical 2 plus 6 radical 2. That's 12 radical 2, plus the hypotenuse, which is 12. So the perimeter is just going to be 12 plus 12 radical 2. The area is 1/2 the base times the height. The base is 6 radical 2. The height is also 6 radical 2. In other words, in a right triangle, base and height are always the they're always the legs. So the area is going to be that. And again, I could put units on there. Sorry, forgot. Okay, here we go. We have 30, 60, 90. So I'll just say this is 30. So this is going to be x. This is going to be x. This is my right angle. So it's going to be 2x. And this is going to be x root 3. X root 3, 2x. 30 across from the 30, across from the 60, across from the 90. And we know that the hypotenuse is 28, which means our x is going to be just 14, which is here, which means that this is going to be 14 root 3. Okay, so now we have all the sides, so we can do our perimeter is just 14 plus 28 is 42, plus 14 radical 3, right? We can't combine that anymore. Area, 1/2 base times height, so that's going to be 1/2, area equals 1/2 14 times 14 radical 3. 7 times 14, 70, 98, 98 radical 3. All right. A square with a diagonal length of 18. So a square, you always sketch out a nice square. We know that these are the same. These are right angles. So when you draw the diagonal, we get a 45, 45, 90. So x, x, x root 2. And we know that it's also 18. So x root 2 equals 18. So once we divide by radical 2 and rationalize, we just get 9 radical 2 is our x. And so the perimeter of a square is just 4 times that, right? Because there's 4 of those sides. So each side, in other words, of all of them are going to be 9 radical 2. So 36 radical 2 is the perimeter. And then the area is just going to be side squared, or 9 radical 2 squared. So 81 times 2 is 162. And again, throw some units on there. Don't forget. Okay, an equilateral triangle with a side length of 4 feet. Okay, so this is, we sketch out an equilateral triangle. Okay, and so we get 4, 4, and 4. So that's actually super easy as far as perimeter goes. 12 can handle that. But to find the area, we need to find the height. And so remember that this is 60 and this is 60. So we split it in half into 30 and 30. So it actually is a 30, 60, 90 right triangle where this side is x across from the 30. This is x root 3. So basically the height in this case ends up being 2 radical 3 is sort of the height. So 1/2 the base, which was 4, times the height, which was 2 radical 3, is going to be the area. So just 4 radical 3 is going to be the area. All right. Equilateral, what am I having trouble talking? With a height of 30. So it's the same thing. The difference is that basically we have a 30, 60, 90, where this is x radical 3, this is our 2x, and this is our x. So this 30 is here. So x radical 3 equals 30. When we divide by radical 3 and rationalize, we end up with 10 radical 3 is our x. Right, so this would be 20 radical 3. So the perimeter of this, right, because basically three of these sides are all going to be 20 radical 3. The perimeter is going to be 60 radical 3, and the area is just going to be 1/2 the base, which is 10 radical 3 by 30. So 300. So 150 radical 3 with some units. Okay, here's we go back to these. Again, I can sort of think about them as x, 2x, x radical 3 is across from the 60. All right. I remember which side is which, so I'm just going to put the sides on here. But basically, if this is 1, this side is going to be 2, and this is going to be just 1 times radical 3, or simply just radical 3. So those are the sides. All right, so we get x on this side, x radical 3. I'm doing them on the inside here because there's room. And then 2x equals 9. So x equals 4.5, or 9 over 2 is always good. And so that's my x, is 9 over 2. And then so 9 times 2, 9 over 2 times radical 3 is just 9 radical 3 over 2. Perfectly fine. Okay, and then we have, in this case, we know that this is our x, this is our 2x, and that's our x radical 3. All right, so in this case, we get 25. Once we rationalize, divide by radical 3 and rationalize, we get 25 radical 3 over 3. Okay, so that's our x value. So that's going to be, I'm just going to write, actually, that's just d, but it's x as well. I don't know. We put in both. It's this one right here. Okay, and star at the same time. I don't know. And then we double that. Well, that's just going to be 50 radical 3 over 3. Okay, so again, I don't know. I think I labeled that one. Just got to listen. All right, I'm probably going to stop at 10 because we did ones very similar to these, and these are good, but they just take a little bit of time. So I will stop because I just want to make sure we have these ones down. I'll stop at this page and maybe add on the last one. Okay, so we know that these are isosceles. So if it's isosceles in a right triangle, it's going to be x root 2. So just 8 root 2 is what we're going to have for this side right there. All right, y root 2. I mean, I kept it already as in terms of y, x root 2, same thing. So when we rationalize, we get 14 radical 2. In other words, it's just, again, one more time. When we divide here, those cancel. So we have to rationalize by multiplying by a convenient form of 1. So 28 radical 2 over 2 is just 14 radical 2. All right, in this case, this is our x radical 3 side, and this is our 2x side, and this would be our x. So we're just trying to find the hypotenuse here. So once we find x, we double it, and we're good. So in other words, we have 14 radical 3 over 3 is what we end up with for our x, and we double it to get 28 radical 3 over 3 is our 2x. And I think that is what that is good for now. All right, I think we can handle the rest, the last page, later. So that's 5.8. I might add it to the key without talking about it. See ya.